Hi, we got few stereochemistry problems. I selected a simple chiral compound, two chiral compound, a cyclic compound, and a meso, and an interconversion between Line and Fischer. So the first one was R2-butanol. So when you write the R2-butanol, what you want to do is look at the name, 2-butan. That's the 4 carbons, and the second position 2 has the ol, right? So you want to just draw a line with 4 carbons and add the numbers for each carbon 1, 2, 3, 4, right? And then second position you will put just dotted lines. Okay, now 1, 2, 3, the priority order based on the CIP. So it seems like R now we solid, that's an R clockwise, right? Now we can just put the hydrogen in the back and OH in the front. That's how kind of the easiest way to do, because if you put the hydrogen in the back in the proper place, you have it right one. Now simple, just put the mirror plane in between, so you get the image, right? That's an enantiomer. It has to be S, we know that. You can check it out. So the OH, just the actual mirror image of the left to the right, right? So hydrogen in the back, 1, 2, 3, the order, CIP rules, and then it gets counterclockwise, right? So check it out slowly, draw it on a piece of paper. That's the best way. Now, second one, the Fischer question. So this is sort of going between Line and Fischer, but I kind of like this way. Look whether this works for you. So you have a line diagram, and we know this is basically the man standing in front of you. The arms, the bow tie comes towards you, right? Like I say, the Dr. Fischer hugs you, right? And now what you want to do, I mean, there is a way you can look from the behind, but I pay attention only to the hydrogen. It's coming towards you, right? You give the priority based on the CIP. 1, 2, 3, OH gets the first, second get the CHO, third gets the lower part. And see, it looks S, but it's R because hydrogen in the front, right? So that's how you want to go. You don't need to do anything else. It looks S, but it's an R. So you can do the same thing for the second carbon, right? So make sure when you write a chiral center, the second chiral center is looks S, but an R. Third chiral center also an R, based on our method, right? So that's it. So you can simply mirror it to the other side, use a piece of mirror or your phone reflection, whatever works, right? And now we know it has to be then S and S, right? You can check it. See the hydrogen in the front, 1, 2, 3 order, counterclockwise, right? Sorry, looks clockwise, it looks R, but it's an S then, because hydrogen in the front, right? You can do the same for the third carbon. Okay. Let's go to the next question. That's a simple one actually. Regioisomer. What's a regioisomer? There's a lot of, it's a bigger question, but just simply it's asking what's a regioisomer. So this is the older method. You guys don't use it anymore. What's the idea? Is it's a constitutional. What's the constitutional? That means you break bonds and stick it into some other place, right? So you have, it's a pentanol. It's actually 2-pentanol, right? You have compound here. You take the rotation 1, 2, 3 order CIP, and it looks S. It is S because hydrogen in the back. Now, if you break it and stick it into another place, the middle place, that's not chiral, because you see the left and the right carbon chains are identical. So it is symmetric. The symmetrics are not chiral. These are achiral, right? So I have another achiral question later. Okay. Yes, dibromocyclic butanes. So the cyclobutane, you look at this one. So simply, let's say we draw that one. Now I'm trying to draw the mirror image. It should be that one, right? So it just mirrored to the other side. Now the tricky part is, so you can take the rotation and you can assign. So it's it's an S. Yes, because hydrogen in the back, it's counterclockwise, it's an S, right? the lower BR, right? And that chiral center. Now the above one, so 1, 2, 3, it's an R, right? Now we expect the mirror to be opposite, right? But the thing is, look, if we can draw an internal mirror plane, if the symmetry is within the molecule and at least 2 chiral centers, it could be a meso. That's the tricky part. So the meso has at least 2 chiral centers and a mirror plane in the middle. So that's how you know that, right? Now, if I have this one don't have a mirror plane internal, you see, no mirror plane internal. So therefore, I can actually draw an actual mirror image, object image, voila. So you have the enantiomer pair now. So that's the difference. If it is a no internal mirror is meso, no internal mirror could be enantiomer, but make sure you draw them, right? Now, the fifth one, so this is again cyclic, cyclopentane, dichlorocyclopentane. I can simply draw an internal mirror that has to be meso. This one, you could have a mirror image, right? So this pair is enantiomer pair, right? Now, what's the achirals I can draw? I can put it into the same spot. So now